Bem, passamos agora para o Snir. Quem não... Ele vai fazer a palestra em inglês, então se alguém precisar de fones de ouvido, é só pegar aí na entrada, tá bom? Snir, tenha bondade. Obrigado pela tua vinda aí.
Ok, bom dia a todos. Mi palestra va a ser en inglés. Si hay algo que no está claro, después estamos disponibles para contestar preguntas. Entonces, buenos días a todos y gracias por recibirnos en otro IFC. Bueno, la palestra es sobre juveniles, producción de juveniles en recirculación, una necesidad que vemos en toda Latinoamérica, en la industria de tilapia en general, muchas especies diferentes, no solo en tilapia, un tema común que vemos casi en toda la acuacultura, especies marinas, agua dulce, entonces, y que ya estamos implementando aquí en el país. Okay, so I'll switch to English. The presentation includes introduction, the challenges, the solutions that we propose and that we're implementing as a company, and a little bit close-up of our systems, a little bit more zoom into our systems, and then conclusions. Okay, in this picture we can see some systems we work with around the world. Basically, whether you're working in cages, tanquered, or in ponds, which are becoming more and more intensified, also for the grow out, or in RAS, you depend on a good source of fingerlings or juveniles that can be vaccinated and go into the grow out cycle para el engorde, ¿sí? And survive, yeah, and make it to the harvest as soon as possible. Okay, a little bit about MAP. We're a company founded by my father and myself. We come from Israel. I've been in fish farming my entire life, but 25 years professionally, different companies, some of the largest companies in tilapia and barramundi and salmon recirculation. Today we're a company formed by many veteran aquaculture experts, and we're coming together to bring, and companies that integrate, that are partners with us, we're coming together to bring solutions like the one I'm presenting here for the industry to solve for some of the biggest challenges. In general, we work not only with recirculation, we work across the entire, what we call value stream. And so we work on hatcheries, and we have a cage project, for example, in Guatemala. We're in production ourselves. That's a place where we test a lot of the solutions that we bring to the markets before we sell them to other companies. Automatic filleting and other processing solutions that we're also now bringing to Brazil, and a lot of byproduct and value adding to the byproducts solutions. And some of the companies that are partners with us, you can see on the bottom, from around the world. Generally about tilapia, we all know, I mean, it's probably the most cultured fish in the world today. It's very hard to get statistics. Latin America is obviously, after China, the second biggest, and Brazil is growing exponentially. But now the situation is that this year, I think, will be the first year, at least in my memory, the tilapia industry may have a reduction in production, at least in Central America and some of South America. and that worries us, and we think that implementing RAS now is a necessity. It's a need that the industry has to keep growing. And this is a recent article from yesterday from Colombia, where they're projecting to have a reduction of 5%. We project it's going to be much more than 5%. Unfortunately, they have a lot of disease challenges in Colombia right now, also in Honduras, in Mexico, and a new strain of Streptococcus, and the other bacteria that are coming into play, and viruses that are expanding, and not only affecting large fish, but also affecting fingerlings, larvae, and even now we see them affecting the gonads of female matrizes, spawners. Okay, the current model is, most of the current hatchery models are in open ponds, like we see in the picture here. Obviously, there's no way to control the biosecurity in that kind of scenario. There's a variable use of different sources of genetics, if at all, or in a lot of cases, no genetics. No reputable genetics is used, and a lot of inbreeding can occur, and deformities, which obviously trigger more and more disease, high losses, and so on. Vertical transmission of disease from the parents to the larvae, and as we mentioned earlier. Oh, sorry. And this is some of the solutions that we're coming up with here in the industry and in other countries as well. Okay, so this system is called Juveras. It's a system, this system was just designed here for Brazil, but we have many different scales of that system. Generally, you can see the numbers there, but number one is a quarantine, where we bring in eggs from a reputable genetic source, and we quarantine them, and we grow those broodstock matrizes in the quarantine until we are sure that they're safe to use in the project. Then we pass them to the production stage, to the reproduction stage, the produras. That's the number two greenhouses there. After that, of course, we collect the eggs for the incubation. Number three, incubras. We pass on to the nursery, nurseras, fingeras, and eventually juveniles. So everything is done in one place with a lot of focus on biosecurity, control, on reduction of labor, automation, and yeah, good, efficient performance overall. Okay, some of the hallmarks, as I said, the design is based on experience that we have from other systems. So we're not really doing anything new here, but we're just integrating a lot of systems that have been tested and are used around the world, and systems that we've designed and built. The production concept includes 7 stages that I mentioned previously for a year-round production, regardless of the temperature outside. So this can produce all year. The efficient operation as far as land, as far as water use, we use very little water. All our designs are built to use very little energy, so low head pumping, as we call, infiltration. Genetics I talked about, biosecurity, and everything is replicable and modular, so we can grow the system in stages as needed for the production. Okay, some of the concepts that we use to design the system. Basically, the whole system is sitting within the red barrier, which is a biosecurity zone, right? We control everything that comes in, everything that goes out. The quarantine is sitting outside, where we bring the eggs, and we also use a concept that we call biocorridors, um, which implies that we separate each cohort of eggs. Each batch of eggs that we collect goes within all the systems in the process on its own. It doesn't mix with other batches of eggs. So we have the ability, if we find a disease, to shut down one corridor without affecting the production of the others. Okay, I won't go into a lot of details of the system. This is the isoras, which is the quarantine, basically, reproduras. You can kind of see here that each system has its own biofiltration. And so the broodstock, the spawners, the matrizas, they don't move. From when they come into the system, they basically stay there for their entire cycle. And that way we prevent the possibility of crossing over disease between matrizas. Okay, next system is the incubras. These are systems that we designed specifically for these type of projects, and now it's a standalone product. 12 jars on each system, temperature control, solids filtration, biofiltration, UV, sterilization. A very practical system. It's giving very, very good results wherever we're using it, and very affordable as well. Then we move on to the nurseras, which is where we use what we call symbiotica or symbioras. This is, just to say it quickly, it's a soup of microorganisms, beneficial microorganisms that we promote in the tank to give the fish protection from disease, from parasites, and a lot of natural feed. Move on to the fingerlings, which is already a recirculation system, but with air, not oxygen, so it's still pretty low densities, 10 to 15 kilo per cubic meter at the end. And then we move to the juveras, which is a full RAS system. Also, we reach 50 to 60 kilos per cubic meter here. Here we use oxygen already, CO2 stripping, biofiltration based on FSBRs, which are fluidized sand bioreactors. And yeah, here it's already a production of a large biomass, because we're getting to 30-gram fish that are vaccinated, that are acclimated and ready to go out, whether it's to the cages or to the ponds or to another RAS system. Okay, some of the risk analysis of our system. There are always risks, and in every biological system, there could be a breach in what we call the firewall, which is basically the stations of disinfection that we have between each stage of growth. And the threat would be a disease, and we design to prevent those risks. Our systems and our protocols, operating protocols, energy requirement, of course, regarding weather. Yes, we need to heat up the systems in the winter. We need to shade them in the summer to have stable temperature. I won't go through all of these, but if you want to see the presentation later. But we've identified the main risks and what the mitigation is for each of them. Okay, in general, in costs, not in a lot of detail, but what's important to know is that we've compared extensive in ponds, like a lot of people here know, in hapas, to recirculation, to this juveras scenario. And what you can see in the graph here, that on the main parameters such as water, property, energy, labor, feed, OPEX, which is the operating cost, and CAPEX, and on return on investment, in all those economical parameters, the intensive, so the RAS, came out favorable over the extensive pond-based system. And so our conclusion is that in a new investment today to produce fingerlings or juveniles, to do a hatchery, it's worthwhile to consider recirculation. Consider our system, in this case, over doing it the traditional way. Okay, some of the projects that we're doing here, some pictures that we can share. And you can see how the design turns into reality, of course, through a lot of hard teamwork and a lot of disciplines coming together and a lot of collaboration. Okay, time frame for a project is about, it could take about 2 years, not 10 years, 2 years from in the initial feasibility study, then we go through the conceptual design, detailed design. Those are all the stages that we go through, 7 altogether stages of development in each project. And then, I don't know, I'm almost out of time, but I'll put a small movie here. I think I may steal 1 more minute. Ok, obrigado a todos.
Obrigado, Snir. Obrigado pela apresentação.